Now this is weird because I can't actually see. All I see is just a big camera lens. So it's all going to be different now. The side two gives me. All right. Good day, everybody. Back again after what feels like a long time. I streamed a bit on the weekends, but and today here in Australia it is Wednesday, so it feels like ages, especially when we were doing several hours every day. But there's a good reason, and that is that we've got a whole new setup here. So you can probably see the angle's different. Maybe you can hear my voice is very, very clear, and whatever my voice sounds like, not too sure. And we're waiting for an HDMI capture card. So thank you so much to everybody who's donated and just said, hey, this is cool and whatever, because yeah, I found my old camcorder and even a shotgun mic, which looks like, I'll even show you, because I reckon it looks pretty pro. There it is, hello world. So we've got this thing up on the camera, and just thanks everybody so much to people who've donated and everything. I mean, I can't believe it. I'm hoping that what I'm doing has helped people as much as other people sharing stuff online has helped me, because that has helped me a lot. It's given me a whole career and everything, which is just amazing. Anyway, enough of the cringe stuff. One more thing. If people are interested, I can go through the sort of networking and sort of IP setup here, because a lot of the stuff that we're probably going to cover in the streams is actually being used right now to make this thing. So one of the big things that's going on is we're using MPEG transport stream to stream stuff over the LAN, just over raw UDP. So yeah, we're going to get dropped packets and stuff, but it doesn't really matter because everything's, relatively low latency on the LAN. The only problem is that, of course, we've got a lot of buffering and sort of some time code syncing issues going on. So I've had to add a bunch of delays, and it's a bit of a hack. But I think sometime today we're going to get our HDMI card, and then, yeah, that'll be one less bit of latency down. So I'm here on my OpenBSD machine, finally. So before I was doing it directly on the Mac, but I'm not doing that anymore because, yeah, I've been using OpenBSD, I don't know, for years, and I think it's a really cool operating system, and I hope people discover more about OpenBSD from this stream too. Anyway, yeah, all right, as I said, enough of the cringe. Let's go on and start hacking away at HLS. So I can't even remember where we got up to last time, but essentially what we're going to be doing is just, between like downloading random streams from the internet and reading the spec, like the RFC 8216, we're just going to fill out our package, implementing more and more of the protocol. Not everything from the protocol, but enough that, we can sort of, at the very least, support, kind of get that 80% of implementation for 20% effort and 20% of the code size. That's the big thing. We're trying to make this a small package. No dependencies, no nothing. Sweet. Okay. So let's set up our tester here. And okay, cool. Now testing is going to be a little bit slower on this poor, 8-year-old laptop. But that's okay. And also we're going to set up our formatter. Somebody in the chat's writing, I like my olo.co site too, gives me 90s simple vibes. Yeah, I have a blog post on there that walks through how it's actually generated. It was a lot of fun to get that working. It's like really dumb. Like it actually sucks the way it works. It's so stupid. I don't know why I did it like that, but Anyway. Oh, sorry, what's this? 1, 2, 3, 4, 3, 4. I'm just gonna have to leave that. Don't know what that phone call is, but whatever. Okay, sorry. All right, let's go. So where we're at is at the moment, we're only doing a media playlist. So what that means is that if we go to teststreams.mux.dev, these are playlists that are only like raw media. Normally with HLS, you've got a playlist of playlists, which gives you, like different bit rates and stuff like that. So that when you're watching the video, you get, you can get like some low latency magic going on. We're only doing this. Oops. Oh yeah, of course I can't do that now because I'm not on OS 10. But yeah, right now we're just doing this guy, which looks something. Wait. Yeah, copy link. Where is that? Copy link. Oh. Here's our plain playlist that we're able to parse at the moment. So next up, we're going to find some more playlists and see like what other goodies we can find. So just as a reminder, we've got things like tags, which all start with a hash and then a bunch of stuff after it. And then we've got lines which do not start with a hash, and these are the actual, these should be URLs to video files. When I say video files, it's a container that has video and audio, or just video. All right, let's go through and get this thing going. So right now, what we probably want to do is actually just find another stream, or like, I don't know. What about this one? Let's see what this looks like. Program ID, bandwidth. Yeah, okay, that's a master playlist, which we don't support yet. Let's have a look at this thing. Let's download that one, see what that looks like. That key does not exist. Interesting. Resolution. Limitless Deadline is asking in the chat, any tips to start writing more enterprise level Go? I can achieve the functionality I want, and it's not messy code, but when I see the way some others structure their files solutions, it seems elegant. Do you mean that the way that you write the code seems elegant and the enterprise level is not? Or do you mean the enterprise level seems elegant and your way does not? Okay, whatever. Let's have a look at this one. If I need to locate it or the code. Okay, so in the chat we've got more stuff here. In each function, Satan's resolution seems like others. Okay, so I'll just speak this out. So I would say enterprise level code looks much better. It seems like others know exactly where they expect. Oh, wait, like others know exactly what they expect their structure to be with regards to where different functions need to be located. Although the code in each function is thought out a bit differently. Is reading more enterprise code good for this, or are there certain exercises, projects I should attempt myself? I know the question is a bit from okay. Okay, so it's yeah. Look, I to be honest, I think the standard that we should probably all aspire to is things like. In the Go standard library, or there's another project that I often look at is this one called upspin.io or just upspin. So this is a project from a few of the people who were on the original Go team. I would say that I'm not. What the fuck? Yeah, I would say that this project is also worth having a look at. This is going to be one of those boring things, but maybe what we see in the enterprise is not always what is, let's say, idiomatic. So not necessarily that it looks good, but that you can read it without thinking about it. That's probably the most important thing. We know that code is read so many more times than it's written. So effective Go is another one. So is that golang? But yeah, if there's any and he says, I can achieve functional knowledge, but when I see the way other structure files, it seems elegant. Yeah, I think that like with any language, like natural language or not, I think you end up just getting a feel for it. You know, our brains are wired for language, and so when something feels off, you know, listen to that. And when you're reading something or saying something or writing something and you don't think about it, that's probably the right thing. Or at least that's the way everybody else expects it to be used. So I would try to look at projects like Upspin. There's a whole bunch of stuff on, I think on the official website now, there's a few projects that they link to. But yeah, I would, apart from that, have a listen to a bunch of GopherCon presentations. So there's things, for example, this is the one that I was at, GopherCon Australia. There's a few, there were quite a few good talks about this sort of thing, about when to use pointers versus values. Testing was a great, that was a really great talk. A couple of talks in that one. Otherwise, yeah, write any code and see how it feels like compared to using the standard library. Not necessarily how it's written, because there's a lot of stuff in the standard library to make it like very portable and very like super robust, which we don't necessarily always need in the real world. Yeah, I hope that's helpful. That's kind of yeah. No, it's cool. No worries. That's, as I say, you know, like I'm learning so much by doing these things, and so if I can share that with people, that's awesome. You know, I'm learning a lot every day. Whoa, this is crazy. You know, so yeah, it's been good fun. All right. So let's try and parse this playlist. So this was from a URL that I've lost now. No, here it is. Okay, so let's grab this guy and put it into what is this going to be? This is a media, just a media one. It's pretty easy. Whoops. And let's go into our parse test. That's actually, we can create a pretty easy test here. So let's go var test equals, actually, to be honest, we don't even need that. What's the what's that function? Open glob. Yes. File path.glob, is it? Oh. There we go. Thanks, Team Manly. Yeah, no, I didn't know that. It's something about this stream died. Oh man, what happened? Let me just kill it for a sec. Okay, that might be better now. Let's just keep an eye out. I'll be able to watch that now. Okay. So as I said, let's just make a test. Let's make a suite of tests rather than just reading this one file. Let's. This was actually recommended in Russ Cox's talk, so we're going to go. What is file path.glob? Is it? Yeah, that's it. Turns the name is all file matching a pattern or nil if there is no matching file. So can we go through all of these? Yeah, let's just try and parse every single one of these. So playlists, let's just do names, file glob test data / start m3u8. Okay, and for underscore name in names. Let's give a name to the test, which is going to be something like, probably do the let's do the base name of it, of the name, and then the test function that we're going to run. Oh wow, I've not typed in like 5 days and I can't type anymore. This is good. Okay. Let's open our files. So start open, name. And if we can't open the file, we just bail out of this particular test because we're very unhappy. And then I think, yep. Should be it. Func t testing.t. We can just bail out of here altogether. Cool. Great. Errors already. This is good. This is good. Good thing we're testing. I'm going to put that here. Let's close that. Make sure that everybody can see. Oh yeah, that's okay. Good. All right. So the test that's failing here is master with alternatives. Test data. Index. Okay. Yeah, right. Okay, let's just do a really kind of shitty test where we just try to, if we get any error, then we just bail out altogether. So we're not really validating anything, we're just kind of hoping that there's no error. Great. Good. Okay, so there's unknown attribute program ID. So that's in master.m3u8. Let's start a master program ID equals. Cool. So I guess we're handling this tag, but then we're not handling these attributes. So this is going to be the boring part where we're just like adding, just filling out the library. Let's go here. Tag variant. Okay. Parse variant. Yeah, here we are. Okay, so in here, I don't think there's a program ID. That's what we're hoping is the case. Don't see anything. So that's the switch there. Whew. So we want to do, I'll just start up the server. So at the moment we're parsing a playlist and we've got the program ID. Where would that belong? These might be in the variant bit here. Yeah. Oh no, sorry. URI. Bandwidth. URI string HLS. program ID. Where is that coming from? I don't see anything in here for program ID. Ah, this could be one of those deprecated deprecated attributes in the spec. Let's double check. If it is, we should really at least add a bit of code to say, hey, this thing's deprecated, we're skipping over it, or at least just, you know, at the moment, let's just return an error and say, hey, look, like we just don't support playlists of this version. M3U8. Oh yeah, let's just open up the RFC. RFC 8216. So this is program ID. Was removed in protocol version 6. Let's add a bit here where we error out on it. Let's do the value. What are we doing here? Unknown attribute. Is that good enough though? Like that? How in God's name do you get started to learn to do this? I'm learning, okay. How in God's name do we even get started learning how to do this? I'm learning Go currently, but this type of programming is so foreign to me. Is there a hello world of dealing with protocols? You know what? There is a bit of a hello world dealing with protocols. I would say something like, I would say the one to look at would be IRC. That's a really simple protocol. And with that, you learn a whole bunch of stuff about how to read specs, how to, you know, how to handle errors, how to deal with hang-ups or timeouts and all this sort of stuff that we don't normally think about when we're, you know, dealing with stuff over the network. The other thing is trying to study other simple implementations of network protocols in the programming language of whatever you're looking at. So if you can find something like not a really complicated implementation, like for example, the HTTP package in Go is, yeah, it's pretty big because it's like super fast, handles a lot of stuff, a whole bunch of backwards compatibility things in there. But if you find something pretty small like IRC, where really the network protocol is really just somebody typing hi, hitting enter, and then, you know, sort of going on to the next thing. So it's not so much about protocols as it is about parsing, I guess. Especially in Go, the net package. Yeah. The thing to do would be to stick with the generic net.con type. Now, the reason for that is that you don't have to deal with all the weird stuff of things arriving out of order and like, yeah, just you know, this interface is, I feel, very Go-like because it's just a magic stream, and that's super Go-like, right? Like you don't have all these kind of, you know, that stream thing is a big deal. You know, it's just a plain IO reader, IO writer. There's a lot of stuff, a lot of things in the standard library you can use to like play around and fiddle with it in a way that I think sometimes I see a lot of things online when you just Google stuff and like you'll see things and they'll actually use like the TCP con or whatever it is, you know, and it'll do a bunch of stuff and modify things. I wouldn't worry about that. I think that, you know, the Go developers have put in a lot of time to get a really nice high-level interface. And then if you want to dig into it, yeah, of course, like you absolutely can. But you can kind of choose how deep to go there. Yeah, I'd say IRC. And because it's fun, right? IRC, it's great. You're just speaking to somebody. Yeah, it's good. Oh, nice. Is it really? Does it okay, yeah. Cool. That's good. I mean, before I was using some old headphones that... I'll show you what else is here. It's like this old pair of headphones, just the microphone on the... you know, that I just... and it does it then, there's no ears on it, it's just the one thing. Yeah. But yeah, no, yeah. As I said on, I made a post and I said, you know, you'll be able to hear me going, oh, wait, so do I need to... Now that's super clear. Really hear the thinking in a really clear, crisp way that you never could before. Do that. So the only error, parsing for unsupported, removed in HLS version 6. Okay, cool. Maybe we can get rid of that master because it's so old that it doesn't unsupported. Test data. Yeah, I mean, with alternatives. Let's run that test. Oh, just be master then. I'll just get rid of that. Okay, there we go. we're just removing that master playlist test because, you know, like it's like very explicitly unsupported, and we've got the error now to do that. So, okay, let's find some more HLS playlists. I was saying something a bit more juicy. Test streams. With IMSC captions. Okay, there we go. That's going to be interesting. Okay, blank lines, comments, looks good. Let's get that one in. What did they call this one? Tiers of Steel, HLS with IMSC code, so Tiers of Steel. So let's go tos.m328. Okay, run the test again. Nice. There we go. Let's find out where that's failing. So parsing, so parse variant, parse resolution attribute. Okay, so we were just looking at that function. I think we've got it here, yep. So parse resolution. Unexpected number 1920. Don't know why that's unexpected. 1080p should be pretty standard. All right, let's see. Let's open the this expected number 1920. Okay. Parse resolution attribute. Oh, no, this isn't. Yeah, this is before that. So we're going to go here, there. Somebody on Twitch says, I was just about to ask if we've gone full on Plan 9, but then I saw Firefox and I'm very confused. Okay, so just a quick, so the stream now works something like, well, it works like this. It's a bit of a interesting IP streaming setup. So what we've got is we've got my OpenBSD laptop with FFmpeg running locally, writing, sending MPEG TS, MPEG 2 video, so that's H.262 codec, over raw UDP to the Mac here. And then we've also got the camcorder. This is doing a similar thing, just doing MPEG transport stream H.264 over raw UDP, also to the Mac. And then the Mac has got OBS running on it, and then we're doing the same thing before, which is simulcasting out to both, where are we going? Twitch and YouTube. So it's got a little command running that, that kind of just like, it's just like a T pipe. So it just pipes it out to the two. And I'm hoping that this fixed the problem that we had before with the YouTube RTMP stream being like pretty stuffed. It was losing it was losing a lot of, I don't know, the bit rate. The bit rate was like super low, like 500 kilobit or something. We can go full plan 9 pretty soon though, because I could run draw term on this laptop and then, you know, go deeper. Yeah, and since we're not using any external packages, you know, we're just using the Go standard library, that actually works fine on plan 9. So I've got a plan 9 VM running. Oh no, actually no, I stopped it the other day, but anyway, yeah, I had one running. So I wanted to update it to the latest release of 9 front. I mean, not plan 9, but same thing, I guess. I don't know. Yeah, but hopefully sometime today we get the HDMI capture device thingy delivered, and so that means that we won't need to do this can just be replaced with just a straight video signal over HDMI. But it was fun to get this working. And it's cool that the camera can actually do that, like direct from the camera. It's doing it over Wi-Fi though, which is like yeah. It works, it just drops like a bunch of packets. But this MPEG transport stream can manage that. It's very cool. That sun's just about to come through. It's very on brand. We have a brand now? What? I was thinking like ghetto TV station things. Yeah, that's, yeah. Poor man's broadcast studio. Yeah, that sounds about right. All right, so we're getting this error with the parsing the resolution. And if I go back to, what are we doing? Test data. Why is it? So we're getting the error that it's getting a number. I wasn't expecting a number. But that's weird. To me, I thought we implemented a rule in there. But anyway, what's happening here is the Lexa is giving the parser a it's giving it a number when it should really be giving it something else. Or something else entirely, I'm not sure. So the Lexa here is giving us a string, and the string, a number, and the number is just 1920. And what's probably happening is that the Lexa is going like this. It's going, oh, let me make sure you can see what I'm pointing at. Can we? Average bandwidth. Oh shit, sorry, no, you can't see. Let me put this. Yeah, that's better. Okay, so as I said, we're hitting 1920 x 800. So the Lexa goes token by token, goes 1920, and then it hits something else. So the Lexa goes, oh, okay, I've hit something else. I'm going to send the number onto the parser and then keep going, whatever I need to do. But what we'd rather it do instead is maybe handle the X or really keep going until it hits a comma. Let's have a look. We're going to have to look at the Lexa. I need a new parse rule. Yeah. Yeah, and then maybe like keep keep reading the items from the lexer. Say, oh, okay, we've got a number. The next thing we need is an X, and then the next thing we want is another number. Is that the kind of thing we need? Yeah. Yeah. Yeah, right now we're splitting on the X, but something I'll need to review how we're actually lexing the attribute value. Yeah, so what's happening here is we're oh yeah, just wanted so anybody just wanted to check now that we're 1 hour in. Does everything sound okay, and is the text clear on screen and stuff like that? This is like super experimental, so if everything seems okay, then yeah. But please tell me if something's fucked up, because yeah, like it's fun to fix things. Nice, awesome. Okay, cool. Thank you. Yeah, cool. And because I think before on YouTube it was really messed up, so I think the ffmpeg command fix that I applied seems to work okay. Yeah, awesome, okay. Who's the little girl behind me? What? What the fuck? Yeah, I was like, fucking hell. Well, because there is some like... Ugh. Parse resolution. Let's do it like how I don't know how to pronounce that username, but Ralok Kaz has suggested. Now, also, I wonder if I can I need to get the chat up on my laptop screen, I think, but just so people can see who or what I'm talking about. But let's get the thing going. Zach. 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 Easy. Okay. Okay, just as Zach says. Let's go. Okay, then we read. What are we going to do? We're going to make a slice of 3 items, something like that. Let's do that. So is the idea here that you're building recursive descent parser, and if there's an error, you pass that along? Yeah, pretty much, yeah. we got 3 items, 3 Lexa items. 1920 x 1080. G 1920 x 1080. Okay, let's. I don't know whether this is the neatest or the fastest. Like, let's say the cleanest way of doing it, but it's easy enough for now. So the next thing we're expecting is just a single string, a string just consisting of a single character, X. So let's do, we can actually just do, I actually think this is clearer, X. Item, and then finally and oh man, I really about preference. This would be a value. Yeah, and that's actually something that I've always wanted to look into, but I've tried a few times, but I just can't get it. You know, so using yak and stuff like that. My brain, I just can't do it. Man, this is ugly code. This is going to be yuck. So we're doing X, and then the number, and then we're going to get the... Ugh, I hate this. And now we're going to get all the strings out. Maybe we want to... Let's do a string here. Then we pass that down to, ugh, I don't know. Oh, yeah, it is too. Should come back now. There we go. There it is. Okay, something to look into. Definitely not enough. Yeah, okay. I'll definitely need to plug this. I need to get a long Ethernet cable. I've got one really long one that's plugged into the actual broadcasting machine, but not into this laptop here. Yeah, it definitely needs a bit of a... We've got to hear it. Twitch seems to be more clear than YouTube though. Ah, okay. Yeah. Okay, let's go on this yucky code. So we can go item. So we're going to go S O equals val, and then we move on like that. Okay, S1 equal val, and then not equal item number. Okay, and let's pass it in like that. Type string has no strings. So if, let me just check, we can see. Yeah, so the error that we're getting now is from, we're getting this error. So the Lex is sending an error through saying, yeah, that we've got, so it goes from our example, we're going, here we go, 1920x800, but that's so I have to Okay, one thing we could do is similar to, so this actually looks the same as a byte range. So a byte range actually is a byte range in the HLS spec looks something like this. It's got 45 at, 8888. So that's just two numbers separated by an at. So here we could actually do the same thing. X and something like that. Turn off this. There we go. Okay. Is that, we silent? Yeah, good. Okay. No extra logic. Yeah, so we just do something like this. To a part, so Alexing A. Okay. Yeah, so in Go, the switch statements, the fall through is actually explicit. So you have to actually say fall through, and then it will. But otherwise, it it breaks automatically. So here but actually this is actually pretty clear like this. We're Alexing a resolution, e.g. Yeah, I think that's actually super clear because it really does work exactly the same. So we'll just do a short number, 640 by 480, or a byte range, e.g. 69 at 420. That's actually, fingers crossed, that would be a great code change that you're just like adding 4 characters of code, no extra lines. Let's see. Fuck. Oh no, of course. Okay, now we can, okay, thank God. Now we can actually get rid of that really like shitty, this gross thing here. I think. So let's go again. So we're gonna go yeah, let's dump that in. And then we can always undo this. So, and then we just and then we try to parse the resolution from the value of the item. And the value of the item of the Lexa should be 1920 by 1080. What? Equals? Resolution equals. Oh, I haven't. I need to read the next. Fucking son of a bitch. What the hell? Oh, because it hits. Yeah, okay, this is what happens. It hits a number. It hits a digit. And Zach's just... so we're hitting a digit. And then it'll try to lex it all the way through. What we could do is, although I don't like it because it increases the complexity, is we can, in lex number, we can actually try to... we could check for an X. But I don't know why this works. Yeah, exactly. Exactly. Yeah, let's, yeah. Yeah, just trying to find that, the lex. Okay, let's see the parser. So byte range, parse byte range. Yeah, so the byte range gets a string as well. So let's find where that's called. Okay. So what the parser does is it actually... Yeah, okay. I think... So if we hit a resolution... Case, bandwidth, program ID... resolution there. So parsing a byte range looks like this. The lexer let me, I don't know whether we're actually testing this though. That's the thing. This particular part. So testing the, yeah. So we're testing the actual, we're testing parsing the strings, but not necessarily testing whether the lexer gives the parser the, that behavior, how the lexer gives the parser these particular tokens. So probably 1920x800. I feel like what we've got to do is when we're lexing a number, if we can peek ahead and say, hey, we've got an X coming up, then we say to the lexer, okay, hey, actually, instead of, you're not actually parsing a number, you're parsing a, either a resolution or a byte range. So yeah, go into that, the lexer changes the state to be, it's called what do they call it? A raw string, I think, in the HLS spec, or an unquoted string, I think it is. So I think that's what we need to do, which is kind of, the number lexer does do that, but we don't want it to emit yet. Because what happens when the lexer emits something, it kind of, it resets the state. So it emits the token that it has, and then it sets everything to, back to, yeah. And then the lexer goes and continues, and the next thing it hits is a lowercase x. And a lowercase x is invalid for a unquoted string. Yeah, so it's like, yeah, that's exactly right. Yeah, but I feel like it's not great, but one way around it, I'm thinking, is in the lexer, we are, when we're going through the number, so we're going lex number, we can peek ahead here. So we can go, if l.peak is X, then what we actually do is we change the state. Yeah, exactly. Yeah, I need to pick an if you get a number, right? And if there's an X, you continue. Yeah, well, we actually change the state of it to say, oh no, actually we're actually lexing a raw string. So this is going to be lex raw string, and I think let's test and see. It's not, we definitely need to put in a little comment here or something saying like, hey, like this is here only for byte ranges, or what's the other one? Or resolution. Yeah. So we're going to do a shorter one, 640 by 480. And then again, we'll do if l.peak is the at character, then we go, ooh, here we go, delimited tuple. But oh wow. Let me write that down. Delimited. Yeah, that's interesting. I'm gonna look that up on the yeah, that's a good one. So the delimited tuple is maybe when we get the, so that avoid the look ahead when you get to the number branch. Oh, what? Oh, mate, you made it up. Oh, come on. I'm like, wow, this is amazing. Okay. I'm deleting my note. There, it's gone. Could I use a regex here before the number so that I can avoid the look ahead when I get to the number branch? Okay. I don't think so, because the way this lexer works is it actually goes character by character. Or rather, it goes rune by rune in Go. So UTF-8 character. It's actually, yeah. And this is, here we go, yep. Yeah. Now, part of the reason we're doing it like this is because it's just a super interesting design that I thought was worth trying to learn about, to use concurrency in a way that I never thought about it before in Go. Yeah. So this is an implementation of this design. Yeah. It took me a long time. I think it took me like 3 days to actually get the lexer kind of. Yeah. Yeah, it took me like 3 days to get the lexer working, which I didn't stream. It was before I even thought about streaming before. I was in sort of rural Western Australia, if anybody, well, I say rural, like, you know, Margaret River in Western Australia, if anybody knows where that is. Very beautiful place. Long way away from, no running water or anything. It wasn't really Margaret River, but anyway, so I highly recommend, it's super interesting, and I've learned a lot by doing it like this. Okay, so let's go back to our Lex. Can we do this, or if L dot, yeah? Let's do it like that. Okay. Is this actually going to work? Just first go. Unexpected number. No, what? Correct. Yeah. Oh, yeah, no, this is, yeah, that's right, yeah, no, you're right there. Yeah, what's happening here is that we're already only peaking here. Yeah, and then, so we need to consume the character and then try and then look ahead again. Peak even one more, so, it's actually going to be in here. Which is actually great. I think this is actually neater. Does this... This might look... This seems right. Because... Yeah, because what we're doing is we're... Yeah, this has got to be... No, I think this is it, yeah. Yeah. So now we'll do a... let's put our little comment here again. I love when like it works like this, because I think, you know, like I didn't come up with this design, right? But you can see how like somebody thought of this so that when something like this happens, it's actually like this, and so you just get to benefit from it. You're like, oh wow, this is amazing. Like I can't believe it's that easy. It's like, yeah, because somebody did all the hard work of actually coming up with the design. All right. Oh no, let's get that. Yeah. Yeah, and then so we go, yeah, because so it goes into a little loop here. It says, okay, we're going 0, 1, 9, 2, 0, and then we go, is the next one we've got X? Okay, then return the raw string. Okay, here we go. Oh! What? What? Maybe when we're lexing the raw string where... Yeah, I think that's right. I'm not omitting the X, yeah. Hey, Dylan. How's it going? Okay, so we're going is tag name. It's this thing. So lowercase x is not a tag name character, because tags can only are, A, B, C, D, E, F, G, blah, 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 all lowercase. Let me just see what that is again. Numbers or dashes, could it? Yeah. Damn. Make a lex string function, no raw. Yeah. I have a quoted, this one here, quoted string, which looks for the double quotes, but maybe this should actually just be a little bit more permissive, rather than checking that if it's a tag name, if the character is something that can be a tag name, that can be in a tag or not, then just let it go. Because the parser could actually, yeah. I mean, we could even have a bit in here that, yeah. Maybe we could just have a bit in here, just say else if, again, we're going to peek. No, it doesn't seem right though, does it? The issue is that I feel like the issue right now is that this lex raw string doesn't actually lex a raw string. It's actually lexing a tag name. So this name is misleading because the meat of the function is actually this thing here. I feel like, yeah, that to me feels like that's, yeah. So this should be something like, and we just maybe shouldn't have this at all. Maybe leave it to the parser to validate it. Maybe, I don't know, do we think that the lexer maybe is doing too much here, or I'm not sure. Yeah, that's, yeah, that's it, exactly, yeah. Lex raw string is just wrapping this guy here. Yeah, that's a good idea. The only thing I'm thinking is that how do we know that lex raw string is finished? It's when there's either a comma or a new line. Those are the only two characters. So really here, instead of is tag name, we should have maybe something like this. If comma or maybe like that. Because I think that's the now I know they call this in parsing. It's a terminal character. Really, somebody says, I've really enjoyed these live streams as VODs. Just wanted to let you know that as a CS student, computer science student, you're an inspiration. Oh man, come, thanks, man. I'm a student, okay? I'm not. I'm a student too, okay? There's a lot of learning going on right here. Yeah. Hill Sharma says, sorry, missed the beginning. What are we doing? Right now, we are just implementing more of the. Well, right now we're working on an HLS package, and this. Oh wow! Thank you so much. Yeah, Acme. Yeah, awesome program. Yeah, there's I can. If you let me type in the. I have to do this. Give me 2 seconds. YouTube. Oh, actually, if you go to the Twitch. No, no, sorry. I mean, like, I'm a student, like a metaphorical student. Yeah. If you, shit, sorry. Is that a link now? Will that work? Yeah. So if you click on that Twitch link, is that going to take you to the right place? Sorry, I'm not. I don't know how. Yeah. And then at the bottom of the page, you'll see a link to the Acme editor, and there's a really fun video that is like a walkthrough of Acme, and it kind of shows off how it works and just as it says, a tour of Acme. Highly recommended if you're interested in Acme. I should do an Acme video at some point, but Yeah, just so busy doing this video stuff, I guess. A lot of people ask about it. Okay, so we were just saying that, yeah, we right now we're writing a HLS package that at the moment just parses the HLS, so these M3U8 files, which are these playlist files. And we're kind of doing the boring bit of just fleshing out our package so that it can handle more of the protocol. Right now we can only parse very basic playlists, but what we really want to do is have it handle a bit more stuff. So yeah, so right now we're parsing the resolution out of this playlist that I've lost. Where is it? TOS. Yep, there we go. This is actually available online if you want to look at it. And does that be like elder peak needs parents, elder peak? Ah, okay. Thank you, Fulbo. Fulbohan. Let's yeah. And this source code is available on GitHub, by the way. Where does HLS sit in the video stack? Would this, or is it bundling the HLS something? This HLS is the thing that is actually a player for what most of us know in the streaming land is actually like our browser or QuickTime or VLC. So it's a thing that actually fetches a text file over HTTP, and then the player reads the file and then finds the actual video files, and it will fetch them over HTTP as well. So this is the kind of like very much towards the end of the sort of whole pipeline. So all the, like FFmpeg and, in Safari and QuickTime and stuff. No, this isn't the video renderer. This is the, what this actually does is it fetches, well, the HLS bit will fetch the video files. And if we have a look, to give you an example, let's open this one. Let me just see, can you see what I'm seeing? Yeah, cool. So in this case, the video player will fetch, we'll do an HTTP GET request for this particular file. And in this file, which is an MPEG transport stream file, that's a media container, just like MP4 or MKV or FLV or, blah, 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 loads of others. And part of this file will contain, the raw bits and bytes of the video and also the audio. So the renderer is actually handled by, other stuff. If you're interested in that bit, there's a super cool streamer on Twitch who's doing, there's a really cool person on Twitch who is streaming actually a video editor that he's writing in Zig and also in Rust. Super interesting. I can't remember the name though, and it's super hard to like Spheroria or something. But it usually pretty high up on the search results if you look for it on Twitch. Okay. Somebody says it's a really good way to show burglary advertisements on stream. Yeah. Yeah. Yeah, right next to the kids shows. That's good. Yeah, that's it. Thank you. Yes. Spherophoria. Something like that. And I remember I was watching that stream a couple of days ago, and yeah, same old like struggling with timestamps. Like, wait, so if we have that many microseconds, 90,000 kilohertz clock or 90 kilohertz clock, so then how many, you know, in converting between durations, and you're always off by like 1,000 or whatever. It's right. Cannot convert. Oh, yes. Philvo, where is it? I didn't take your advice soon enough. Oh, look at that. Beautiful. Yeah. So let's actually see the little, let's see what diff that actually is. Because to me, this is kind of like a valid, this is like a good increment. That it's small. Oh, shit. Yeah, see, so then, okay, so after all that, it's just like 2, 1, 2, 3, 4. I think then we can actually get rid of the one of the cases where we're looking at the if I find that, do we need to check twice? So what I mean is that we're going in Lex number. So I just open this thing up. Do I need that? Yeah, we'll keep that for the moment. Open that up, and then I don't want that one. I want this. Yeah, I think so too. Yeah, because we're checking it. So the I think we get rid of this one because we cannot start with an at or an x. That's invalid. So I think it's going to have to look like this. Oop. Oh, oops, yeah. I think it'll look like that. Yeah. So in the end, the whole thing took up that many lines. 1 line of code, 2 lines of comments. What's in there? It's empty. All right, let's try again. Oh, wow, from Thailand. Hello. Wow. Hey there. Hi from Australia. That's so cool. So good. let's oh, right. Okay, F commit. Hey, oh. Cool. Have I considered using a subset of the examples as regressions or integration tests? Yeah, that is a good idea. Yeah, that I think one of the ways, let me see, we did a little bit in this. Right, where's the other test? But yeah, I think it's a really good idea, yeah, and it needs to have names and stuff like that, because at the moment this is like almost like an integration test in the sense that it just like smashes everything through and then just checks if there's an error at the end, which isn't really what we want. I mean, we want that, but we also want the kind of yeah, that's a good idea. How do you think that we would do that here then? Maybe just making a fake little playlist that has just like one tag in it. Something like that. Or maybe, yeah. We could even have it in line rather than in a file. We could just have like a string and then yeah. So yeah, I think yeah. Yeah, that's right. Yeah, some kind of like, because this is a good little example because it has a whole bunch of like, you know, it has this one tag that's got a whole bunch of stuff in it. But say, for example, the test that we just did, maybe we could have something like, you know, let's call it resolution.m3u8. And let's say it starts with, so we knock out all this stuff, and the only thing it has is bandwidth and resolution, and and then say like that. And then we just got like another, some file.mp4. I think that's what Ralok Kaz backwards was saying. Yeah, and that parses too. So then when we try and parse this thing, we can start fiddling with it. Like, for example, let's just do this. Let's put an extra X in there and see how it handles. There we go. So now we know that the test name is resolution. Yeah. Yeah, really good documentation, yeah. Yeah, so let's actually just, I think it's pretty good just like that. I mean, this is, I think that's a valid playlist, I don't know. But certainly, yeah, there was a talk I was listening to the other day which was talking about tests as a communication of intent. So what that means is that the code kind of, the actual, like this code tells you how to get there, but the test code is like documenting really what you're expecting. And that's super important too. It is a good idea though, because we're just about to move on to the next thing, and that's exactly what we want to test. So let's go back to this guy here. Let's test something that's kind of trickier. Let's do, this is a good one, closed captions equals none, because that's a special case. And if I remember rightly, here, I think we have a bit closed caption info. Is that it? Closed captions none. Maybe not. Here we go. Or comma separated values. There we go. Let's test this one. Let's make a new test. Let's call it closed captions. Let's dump everything except for that one. Get rid of all that. Let's test this. So that should pass. Yeah, great. Closed captions. So this is going to be we're going to test that the variant, so there's, in this playlist, there's one variant. That's from this ext extreme info. So variant o dot closed captions does not equal the string none, then we got to error out. Let's do just CC. Let's do that. Don't have to repeat ourselves. Okay, let's just double check, right? Yeah, right. Okay, cool. Easy enough. The reason this one's a little bit tricky is because the closed captions can be this or a bunch of like 1, 2, 3, 4, that sort of thing. So maybe we can check. Maybe we actually want to check that that works. None or comma separated values. Let's try and break the program, right? That's actually definitely more complicated. Hi there, Kai314. Good, my day is good actually, thank you. Yeah, it's getting hot again now. The sun is just starting to come in, so I have to put my sunglasses on in 2 seconds. And the stuff's starting to heat up. Oh boy, that camera's getting hot. Hold up. I might be able to close these a little bit more. Hold on. Oh yeah. How does that look? Oh, that seems okay. Oh no, that's a bit too bright. Let's do that. Oh yeah, that's better. Okay. Yeah, yeah. How was your day, Kai314? Six. Any faster? I don't know. More from the fizzy drink, a few burps, yeah. Okay, so it can be a quoted string or. Let's try that. So let's do none, and then let's do another variant. And And this time it's going to have like, you know, something and then another. And let's go down, and then we're going to go do the 1 and CC2, and we're going to error out here as well. Oh, want that, got that. Missing equals after attribute name. Well, we broke it. So, here we go. Go seems like such a delight to write. It seems so simple like C, but with an actual standard library. Yeah, it is. Plus like a bunch of, like a lot of extra stuff on top. Yeah. Like with the, I think the runtime gives you so much that, like, you know, lets you, I guess it's just got a balance there with, you know, all the garbage collection plus, the errors as values thing. Yeah, that sort of thing. There's not a lot of fanfare. You just kind of write the thing and then, Mission accomplished. Yes. Yep. Oh, sorry. That is actually invalid. So let's try that again. Seems great. I tried Rust and it was like, oh no, it's another C++. Yeah, something about the way that you are kind of like, you've got to tell the compiler all this stuff. It's a lot of, oh, wow. Zach says, I wrote Rust for 2 years, one of those professionally. I'm over it. Wow, I think it's just one of those things. Like, I don't know. There's obviously some like amazing stuff going on there, and what you can do with Rust is, like, it seems to collect a lot of research into some really amazing stuff that I can't quite understand, but people who do understand have sort of walked through it with me. And it's been super interesting, but for me, my brain doesn't really work like that. I'm kind of like, no, I really want to just return an error. Like, I don't want this sort of, just values, giving, you know, here's an error bag, here's a value that you want, you know, just super dumb. And some people don't like that either. Some people, you know, but for me, just like, it being dumb like that is helpful for me to think about problems and stuff like that. That's kind of how it works for me. All right, let's run this thing again. Ooh, there we go. Yeah, we didn't get this right here. Want closed caption something another got actual fully quoted something. Well, that's... Here we go. Mr. Rallick is saying, Rust taught me a lot of best practices for systems programming though. It really shines as a very angry tutor. Stubborn as hell, but shows you the safe way. Yeah, that's... yeah. Let's have a look here. Closed captions. So what we were expecting here is that the token, the item that we're being sent through from the Lexa actually, you know, has a comma in it and all this sort of stuff. So but what we're getting instead is quote, and then we're hitting a comma and that's it. So we're back into our Lexa. Lex Q string. So we're hitting a double quote. Oh, look, this is wrong. Nah, my data's wrong. Look, there. That's it. Should be a quoted string with a bunch of commas in there. Just like, yeah, my bad. So this one, so we got a quoted, where's our long quoted string? Yeah, here, like this thing here. So we've got ABC1 blah blah blah, comma, some other string, comma, and then the final string, all quoted. That's what we want. So yeah, so let's actually now that we've actually got a valid playlist, let's run the test again. One closed captions, I got something another with double with quotes. We're not trimming the quotes. Do we need to trim the quotes though? We should really, because you know we don't. Yeah. So we're going to take that and then trim the quotes. Value of type string as array of string. Oh, whoops. Like that. It's not super. Oh, yep. There we go. Got it. Alright, that's good. Let's commit that as well. Ooh. And then let's keep this up. This is really just testing because we actually had it. Actually, that's it, yeah. Wow. So we've gone through all that stuff. Let's find another playlist to test. Although there are still more on the teststreams.mux.com. Maybe we should go through them just because those are like really available for everybody. Yeah, I actually, yeah. Let's go through those test streams on Mux from Mux. So we've done the 480p one. We've just done, I think we've done that. Let's just double check. So that's the tiers of steel. Independent segments. That's an interesting one. I've actually seen that before. Another thing that I want to check is this sort of thing. I've noticed quite a bit of, like sort of variance here, where numbers can either be the integers or floats. Yeah, there's just you know, different precisions and all this sort of stuff. So maybe we should do let's create a test that actually just gives the thing a whole bunch of different frame rates so that we know that we're handling that correctly. So the frame rate is going to be in the variant. So let's have a look at this. The variant, the frame rate is, oh, we're just saving that as a float 32. Well, let's test that, but then with an integer there as well, maybe. Because there's a bunch of standards that are like, you know, PAL is 25, exactly 25 frames per second, I think. And you got 24 point, what's the other 24 one, 24 point? I can't remember that actually. Anyway. We can test that. Codecs, yeah, subtitles, closed captions we're doing. Okay, let's test the frame rate. Let's grab all the common frame rates. So let's learn a bit about video. I guess people watching this might know this, but if you don't, there's a bunch of like standard frame rates that we see around the place. So frame rate standards. Yeah. Okay, cool. So, so this is, let me see the frame rate, broadcast video formats, here we go, yeah. So there's a bunch of standards around the world. So here in Australia, we use this PAL format. This is a good, here we go, this is good. So here the frame rate is like 30 or 29.97, I can't remember. And then you've got 25 frames per second here. Oh yeah, we frozen, yeah. Damn it. Fucking Wi-Fi. Actually, hey look, this is great. Like it's cool how the way that we're actually streaming right now from using MPEG TS over raw UDP is almost exactly the same as what you do if you're like receiving TV with an antenna. It's just like send only. And the actual container handles all the like errors and all sorts of timing and all sorts of shit. So if like the stream fails, you just start it up again and the the player will just go, oh yeah, okay, well, I guess we're back again now. And then it'll resync and everything without any coordination, like because there is no application layer. It's just raw UDP. There almost is no protocol, I guess, is what I'm trying to say. It's really weird. Okay, so as I was saying, yeah, there's different frames per second around the place. And the most interesting thing is, at least for nerds, is if I remember rightly, the actual playtime duration of Lord of the Rings is like a little bit different depending on which country you watch it in. Correct me if I'm wrong, but now of course this is different nowadays, but I'm talking about in the old days, when you had it on DVD or even tape. You would because let's say in Australia, it would run at 25 frames per second, but in America, it would run at, in the green areas, it would run at 30, right? Yeah. That's it. No, yeah, that's it. Is it from that? Is it from that? Yeah, because then it like fits the phase, so then you just, for the old CRTs, right? Yeah. There you go. That's cool. There you go. I actually never thought about that. That's super interesting. Anyway, so yeah, in the blue areas, Lord of the Rings was a little bit longer because it was only running at 25 frames per second, whereas in the green areas, it was yeah. So there you go. So what we can do is we can just test like the sort of common values. Yeah, that's it. Oh man, I love these old retro video game things. It's just amazing. The fusion of like analog and digital and gaming and code, it's just like, wow, crazy shit. Love it. Yeah, there's some geniuses like that. Yeah. And especially back then when it was all new, right? Like, I mean, man, yeah. Yeah, there's some weird things when you get into video. Like the ones that I also find interesting is when you have the I've had to do a bunch of stuff with the timing. Yeah, keeping things in sync, like audio and video and like transmission and receiving stuff is, yeah, when you have all these video stuff and synchronizing each thing up is a really weird yeah, it's an interesting kind of problem where you're dealing with like actual hardware clocks that are ticking at a certain frequency, and if the precision is okay, and if you're out, depending on what type of like arithmetic you're using, like how can you adjust? It's like really annoying problems, stuff that you wouldn't, like stuff that you normally don't think about, but oh yeah. Okay, here we go. So let's go scan lines. I want to do like common frame. Maybe just do. This sucks. This is fancy film. We're going to have another one which is 29.97, and that's, I can't remember exactly which one that is. So this, just trying to find what the Okay, so we've got here, that's, oh yeah, that's like 10%. Oh, what is that? That's 1%? 0.1%. And then we're gonna have here, let's do 30 point, let's just do 30.0 like that. What did they say? It was NTSC drop or something? NTSC film. Let's write this one down. 23.976. Good test. Let's do this one. 23.976 is NTSC film. .m3u8. All right, bit of fun there. So 24 for the film. No, yeah. Yeah. 25, no comma, 24, 29.97, SSC. Let's call this NTSC drop. NTSC film, and then let's get a really high frame rate one. I guess it'll be like 60 frames per second is what you see on YouTube and all that sort of thing. So let's grab a example there. So that'll be, oh, screen froze again. No. There we go. I don't know why it's actually doing that. No. I'll just. $60 FPS. Let's do 60, okay. We'll just add loads of zeros just because it doesn't make any sense, but let's just test our implementation. Yep. Cool, okay. Let's go and actually test this thing now. So we're going to go test frame rate. Let's go. Let's just do rate is going to be all of these values. So we're going to have 24 point, O. Oh yeah, that's actually true. Yeah, we need a t dot cleanup, right? No, no, no. That's actually a good point. Yeah, yeah, yeah. There is a special thing, t dot cleanup or something, which is yeah. I can't remember. Anyway, I'll hold on. A sec. So the values we want here are going to be exactly as array of string, array of float 32. 2400, 25, we want 29.97, we want 30, 23.976, and we want 60, something like that. Let's just see. Let's see how that thing flies. And we're going to go through all of the variants that we've passed, which are these. You know, these are all different variants, as in these all point to different streams. So let's go through. If v dot, oh, we'll do I. If, do we even need that, or can we just do that? Anyway, yep. If v does not, if let's just do that without specifying the precision. I think we can do that in Go. I can't actually remember. So I'm going to go want rates I. What we actually got was v. Hey, let's test that. Oh, v dot frame rate or something. So this is our frame rate. There we go. Frame rate. Not equal rates I. Oh, frame rate again. Oh wow. Okay, so apparently that worked. Let's just print this thing out just in case, right? Oh, let's do v dot frame rate because I want to test that we're actually maintaining the precision. 24, 25, 29.97, 30, 23.976, 60. Yeah, okay. That seems to be okay. Great. Tests that we parse oh yeah, do we need to do a do we need to do something like do we need to round it and then test it? No, we can't round it. Yeah, no, you know what? This is a big noob thing for me. I always, this float stuff, I've never really quite understood. Oh yeah, check the bits. Yeah, that actually. They are, although in a way, you can actually get the. Do this. How does Go actually compare the floats? Here we go. Let's just check the spec quickly. I mean, let's just do it for the stream, right? And compare that. Yeah. Yeah, but really, like we know that there's 32 bits there, so we could just kind of go through and actually wait, no, is that even how it works? Look, to be honest, I'm so like I never understood floating point really well. Is the audio lagging? Okay, hold up. Maybe it might grab sync again now, I'm not sure. No, it was just the how's the sound now though? Is the sound okay? This capture card. I'm looking forward to that arriving. Getting it into OBS is a bit of a hack. Let's see. Still not arrived. Yeah. just floating point types are comparable and ordered. Okay, well, that's all right. So let's maybe that is okay in the end. Let's commit that, because I would say that is a sort of at a yeah, like a specific, yeah, at a specific test for floating point integer combo parsing. And, you know, and whoops, and it's an important thing to get right. Actually, it's not just video, in AV. There we go. Let me just check this thing on YouTube. Oh, yeah, doing a quick job. Oh, that fucking hoi hoi. Oh, the Twitch still audio problem on Twitch. Ah, man. Okay, then for sure it's something to do with. Oh, I can see the audio actually clipping. How could it be clipping when I haven't even changed anything? Hold on. Input 1. Let's try that. So if I go down, that might be a bit better. Oh yeah, it's on one channel, it's all right, but we're going 2 channels, so let's just do that. That might be better now. Not a go. Oh, it is a lag clip. Oh, not a go. Okay, yeah. Okay. Just trying to think how to fix this live. How are we going to do that? Oh, I know. I've got an idea. Give me a sec. Hey there. Okay, so I'm just on the different microphone now, so going to change this to be. It started. Yeah, okay. Yeah, there's some okay. I've noticed actually a drift. Yeah, that's a tricky one. Okay, for now, let's do this. Let's adjust this time. So we're gonna go to. So I do need to have a break. Been going for almost 3 hours now. Yeah, yeah. Yeah, let's do this, and then maybe magically it will be okay. I think that's right. Yep. Okay. All right. Hey, listen. Thanks everybody. This has been like, you know, I'm having a lot of fun here. So, it felt really weird to be away for a few days. So anyway, I'm not even okay. See you guys in 10-ish minutes. And Null Void, where are you? Why? I can't believe it's like almost not even 5 a.m. and you're going to the gym. That you, what the hell, man? Hoi hoi hoi. I'm not really back. I'm just trying to work out this thing. So that is So I wonder how that looks now, or what it sounds like. And is it sort of in sync a little bit if I go left, right? Yeah, okay, all right. Yeah, okay. There we go. Okay. And then how that level, that gain might be a bit better now. Hopefully. Cool. Oops, wrong mouse. Okay, sweet. Nice. Yeah. Somebody said, "Oh, can you add background music?" And I said, "No, people. I don't know. I don't want to choose the background music. Everybody can choose their own. That's yeah. I don't know. I'll just double check this is all right. So, okay, cool." There you go, and that. Yeah, I actually accidentally showed some copyrighted footage from a Australian TV. Yeah, I actually normally don't listen to music either, yeah. Yeah. No, it was like yeah, the background. There was some stealing going on, but not of the footage. Cool. Okay, so that's our crazy setup there. We can close that. Running, let's oh whoops, I accidentally left the tests in. Hold on, let's printing. Okay, that's now going up to the internet. So now anybody who wants to get that, we can go here. Pro streaming. Let's have a look at maybe this playlist here. Let's see what it looks like. Oh, is that just gonna be that one? Oh man. So for another test, let's just pause this playlist and just see if we. No, that test streams website is from a tech company called Mux, M-U-X. That's this Mux. I won't open it on my laptop because it won't be able to handle the website. But yeah, it's like they kind of advertise themselves like Stripe, but for video streaming or just for video. Yeah. They're kind of stewarding this. Yeah. They have a this Slack channel that's got a bunch of people who work in the video sort of tech industry in this chat thing. And then, yeah, they run a conference and all this stuff. So, yeah, if you're interested in that sort of thing, I'm actually going to the Sydney meetup tonight, actually. Actually, I need to leave in like 45 minutes to that. So, yeah. So, yeah, they're having a meetup tonight, yeah. Yeah, so if anybody's in Sydney, then we'll be in the city. Okay, so what I want to do is I'm doing copy link. Save this call. And I'm losing it here. There. Have we saved that one? So no. Okay, it's BBB. Oh damn. Okay, so what? So in there, oh man, that's so annoying. Okay, let's go. Let's open up our master. Huh. Where's the version? Ah, there. Okay. Let's knock out this program ID because. Hi, how's it going? Yeah, it has been a little while. Yeah, I know it. Almost 5 days without streaming or something. Felt like a long time. Okay. Cool, unknown attribute name. Okay, great. So now I can start filling out more of this. So let's look at the stream that we want to parse, the playlist. Let's go into our parse and let's go. So we're going down and we're doing the variant because this is extreme INF, which is a variant. And then we're going to go. And eventually there's a name. Now, why haven't I got name here? Should we check the spec and see? Yeah, right. I don't actually see. In the spec, I don't actually. Let me have a look at this. INF name equals that. Where would we put that information though? Okay, we're gonna have a look again. So close caption, you can see all the common available with that variant stream. Yeah, okay. iframe. So we're just going to go through and just check the attributes that we can get for this tag. Bandwidth, yeah, resolution. Yeah. Maybe it's like a generic attribute that can be attached anywhere or something like that to any tag. Let's go name. Awesome. any burps? Nah, well, you know, I don't know. You got to listen, mate. You know, you got to, yeah, you got to keep an ear out. I don't know what that 100 means. But thanks, yeah, I'm enjoying having everybody here. It's great. I'm not enjoying this, looking for this attribute though. Name, why, where is that? Of the rendition. A rendition. Okay, so we do have a type for rendition. Well, I thought we did. Oh, rendition, here we go. Media. And that has a name. But the attribute is meant to be under that tag, but we're getting it under this tag. I don't quite understand. It could be. Do we have a custom one here? No. Alright, well, we'll just have to... Yeah, not sure how to handle that. But I mean, yeah, indeed, it is. It's an unknown attribute, yeah. I mean, it's not even in the spec. Okay, maybe we can... Resolution, bandwidth, codecs, yeah, I mean... This one. Solution equals that, yeah. Yeah, we were just looking at where are we? That one. So go here, test. So in this playlist here, let me just check. Oh, are we still? Yeah, yeah. Yeah, so in this playlist here, we've got, you know, this is a variant. And what we're getting is, we're getting this here, a name, but this attribute is not in the spec. Now the thing is that I couldn't find it anywhere in the, I mean, I can see it for what is describing a rendition. And there we have a place where we can put the name. But a rendition is, that attribute is under this tag. So of course we're erroring out because we find this attribute that just doesn't, it's not anywhere. I'm wondering whether, I'm not sure about the custom attribute situation. I know that for one of the tags, that is this one here, date range. There's some custom stuff you can put in there like that. Yeah, yeah, the EXT media. Yep. That that EXT media tag, that's the that's called a rendition. Like that's kind of the name that they give it. And yeah, and like here. Yeah, so not sure how to handle it basically. All right, it's getting late for me. It was lovely watching Lane. Thanks for sharing. Hey, no, listen. Thanks for thanks for hanging around with us. It's a lot of learning, yeah. I don't know what this 100 diamond thing is. That something it says like I sub to my YouTube? Oh yeah, cool. Yeah, I know. I'm kind of streaming to both right now. I don't know if it's a weird situation. People, yeah. Yeah. Hi there, Kyle Zane. Ignore it. Yeah, I guess. But I don't know if that's yeah. Yeah, I've got it. Yeah, but there might be a thing in there about custom tags or something like that. Custom attributes, sorry. So for example, if we go program date time, date range. Oh no, that's that one. No, so in the, yeah, weird. So in this date range tag, they actually say, hey, you can put a, client's defined attribute. And we've implemented that in our package. So we've got a, if we go to data range here we go, we've got this custom thing. Yeah. Sure how to, I guess, yeah. Let me just, maybe we can do a web search using something like Google. Yeah, exactly, yeah. Oops. Here we go. Here we go. Look at this. Look at this. It's in the Go package that we, this is the other package that we were dealing with. Okay, here we go. So this is the one that we, yeah. This is the one that's abandoned. That's written in Go. That was kind of the inspiration for, doing something like this. So first commit, yeah, that's right, yeah. Yeah, so yeah, it's pretty old, yeah. Which is fine, like it's not, I don't think that's necessarily a big deal. It's just that, yeah. Yeah, exactly. So true. Yeah, so true. Okay, so what we got here, yeah, right. So they've actually implemented it and it's non-standard. So I feel like what we want to do here is maybe like, let's just read it and then ignore it. I think I'd rather throw it away than, at least for now, because, I don't know. Do we need to be strictly compliant, or do we just have to be like compliant and then not, not support the thing? For now, let's handle name, but just not do anything about it. And then we'll just add a to-do. Wowzer is a big software as a service that, why is that? I can't remember whether it's a, yeah, okay, so it's a proprietary Java sort of, and streaming protocols, on-demand streaming, other streaming. Yeah, okay. Yeah, it's like this. I never actually knew specifically what it was. I just knew that it like generated, like it was like a server that like generates streams, but it's actually a bit of software that, Java software that looks proprietary. Yeah. I don't know, there's a whole bunch of custom shit that it does. There's like these weird like wowzer tags or whatever. But I think it's a pretty big deal in the sort of enterprise world. Let's just do a link to this. go. Let's save that as well. Yeah. Go. Good little puzzle. All sorts of little things everywhere, aren't there? Jeez. And then now the test I actually want to do is just do a kind of a test that we're getting all these things right. So let's go parse test. Byte range. Maybe we can just leave it like that. Actually, no. What I want to do is just quickly print out a playlist and see what it looks like in full. We're going to go here. We're going to go name. Yep. Ooh, all right. So that's there. Let's skip ahead. I want to see the one that we get for looks good so far though. There's nothing really weird in here. Like there's no empty playlists or something like that. Segments, variants, there we go. Bandwidth, yep, codecs, yeah, looks good. No, codecs is wrong. Look, see, we're not trimming the quote. So we'll have to fix that up now. Let's fix that up. So that's codec. So that we need to do, and then I wanted to grab was, what was that thing that we were just working on then? Was the golang, let's go. Yeah, that's it. We wanted to, oh shit, what were we just looking at? I can't fucking remember. Damn. Codecs? The variant. Yeah. All right. Cool. Now The next big bit we could do is actually try parsing these. We could try moving on from a media playlist and try parsing a master playlist. So we just go back to what that looks like is. Oh no, sorry, we have been doing that. Yeah, let's just try and find some of these things: session data, rendition. Let's find all this sort of stuff. And I don't know whether we've actually parsed playlist, variant. We're doing resolution, rendition. We're parsing apparently. Yeah, but we're not. So the rendition, yeah. I want to do session data. Let's find that somewhere. No. I think there was one of these actually had session data. Hi there, Nico. What's up? Try these examples from Apple as well. Media sequence. Media type. So that comes from, that's the rendition. Channels, characteristics, language, group ID. Okay, that's all pretty easy. Default. Okay. In-stream ID. Yeah, we've done that too. We can go now maybe looking at audio equals audio. Done all, we can handle all that. Version, media sequence, yeah, do all that. Now, a really cool thing that we would probably want to look at next is low latency HLS. Because latency is really what's fun about this video stuff, right? Latency is the stuff that, you know, when you're in like software jobs, you often don't get to, you know, latency usually doesn't matter. I mean, it does, but like, let's say that it's not usually prioritized. But with video and AV and all this streaming stuff, latency is you actually get to work on latency. So that this actually might be fun. Yeah, there's a whole bunch of new tags and cool. So this is pretty boring. I'm just reading through, just seeing if there's any other like, you know, major sort of you know, stuff that there's more stuff to test. I mean, we could do the media segment encryption. I don't think we're handling that. So if I go to, oh, and session data, yeah, that's probably the two things. Oh, we need to handle this independent segments. We can actually test for that. Let's do a nice easy one just to get us going again. Let's just implement parsing the independent segments Boolean. I think there's a playlist already with that set. No, or not. Excellent. Okay, TOS wasn't it? Ah, there we go. Yeah. Okay, let's get this thing. So, independent segments. Here. What's the next step? Next would be to maybe well, the other day what we did was, sorry, my eyes are super itchy. I've got this medication I'm on. It's so annoying. Anyway, yeah, after getting the parser right, I think writing an HLS server would be kind of fun. So one way to do that would be to, for example, one thing that we did implement already was a HLS proxy server, which didn't really do anything except for like inject sort of ad breaks, which was a very funny sort of ad break that we had that some people remember. And that's just kind of like a testing of the, yeah, a way to test our package. The other thing that we could do is, one of the things that I want to get going is, right now we've got these streams going, and right now we're playing them over Twitch and YouTube. That's cool, but since we're doing this, we should be able to get the thing self-hosting. Normally we'd use something like FFmpeg, and we can and we will still use FFmpeg, but some parts of it we could actually you know, use our package to do some of the work. So perhaps one of the things that we could do is like have FFmpeg read this stream that's being sent out now over RTMP, write a bunch of video segments containing the video and the audio, and then, okay, and then done. And then now get our package, or sort of, let's write a little command line utility that, let's say, like reads a directory of mpeg ts files and then makes a playlist for that. Normally, FFmpeg has some magic flag to do that, but you know, you got to know what that magic flag is, and it's no fun. So we could probably do that with, you know, we could make a little command line tool that, you know, imports our package that we're writing, and yeah, something like that. I mean, in theory, we should be able to do that now. We haven't done a lot of the bits where we say we've got our playlist like this in our data structure. We haven't done a lot of stuff where we actually write the playlist back out again in the M3, like, you know, the actual, like, the text format that's required. We have a few bits and pieces done, but not everything. Just enough for a really minimal server, or a really minimal, writer, let's say. That must be uncomfortable. Oh no, it's okay. It's just like an injection for for dermatitis, and it works really well. Like, it works amazingly actually, but yeah, you just get these weird side effects. Yeah. Bro, that's why I never see you online. Why? Oh, what? Oh, wow. So you're... Okay. Damn. You're awake now? Any farts, bro? No, I don't. What about you, Kai314? Do you have any? 2 foot are you in the ocean? SF Akuma just launched a new SF6. Hey, good morning. Good afternoon from Australia. Oh, Street Fighter, wow. Yeah, good morning, Elias. We have a whole bunch of new, gear here to do the stream, and we've had a couple of hiccups, but actually it's working okay, which is amazing. Good 146 from Florida, USA. Oh wow, from Florida, jeez, wow. I bet it's nice and warm there. All right. Inside a hollowed out tree. KY USA. KY. Is that Kentucky? Yeah, wow. 81 degree water. I don't know how hot 81 degrees is. I mean, I know how hot 81 Celsius is, and that's fucking hot water. I'm watching it a while, I'm impressed with what you can do without LSP or hard. Oh, language server protocol, yeah. Hey, everything's just text, right? 27. Oh man, that's warm water. Damn. That's yeah. I've swimming. I went down to like Mexico and Belize and stuff a few years ago, and the water was so warm there. Up north in Australia, the water gets really warm, but it's not that hot. It wasn't as hot as it was in the Caribbean. I think the water's so shallow or something. I don't know. It's crazy. Yeah, wow, okay, yeah. Yeah. Golf cart, yeah, okay, yep, there you go, wow. Oh, you're in Rio. Oh, hey, my best friend is from Rio. Really cold all the time, and the water gets it was usually 20. Oh, really? That's interesting. Wow, that's amazing. I thought the water would be warm there because it's pretty, it's not so far away from the equator. Yeah, interesting. There you go. Yeah. There you go. Yeah. Super deep. Yeah, I guess so. Yeah. Yeah, there you go. Interesting. Yeah. Yeah, it's funny. So like up, actually, oh yeah, you're right. Yeah, shit. Oh shit. Yeah, I do. Yeah, I need to meet my friend. Okay, let's. What I'm going to do is write down for next time what we're actually going to do because I didn't plan for this one and shut it down. That's how do I? Sorry. Yes, there we go. Yep. Just make sure that's not echoing. Yeah, yeah. Should be right. Okay, that's coming from in the built-in microphone. Best random find from the algorithm. I hope I'm just no, big time. Yeah, yeah. Yeah, so it should be on again. Definitely be on again tomorrow. I don't know. Yeah, the algorithm thing. I still don't understand why or how. Or some people posted about it on Twitter, and apparently they went really viral. So yeah, it was. I've never been have a tree in my room. Yeah. Nah, it's not just the but cool. Let me ask anything. Good project ideas that would be really. Whoops. Hello, a few people tapping. I was about you almost forgot to. I think that there's a whole bunch of. I think there's a whole bunch of C libraries that people use CGO for, but would rather it be in pure Go. I can't think of any off the top of my head, but I know there's so many things that people always talk about. They're like, oh my god, CGO sucks. You know, this is where you call C code from in Go. I think that if you've got a C background, I mean, man, that's probably like, yeah, that to me, that I think people would be like, oh my god, thank you so much. Yeah, maybe let me just think of something. Hold on. There's some Seago stuff. What do people use? But really, like, I mean, I guess anything that. Yeah. Yeah, the tree. Yeah. Actually, the problem is that they grow down and they try and get down to the ground because I'm on the second floor of the apartment and like I mean I only have one floor, but I mean like I'm above the ground, and so they want to go down, and they try and find little ways through the because we're in like 100-year-old house, so. They don't grow upside down. Well, actually, I flipped my video, so yeah. I think they grow upside down in Brazil as well. So let me just remember for next time. So next time we're going to do the parse the session data. And we're also going to parse the maybe we, yeah, no man, like let us know how if you come up with anything, and stream it if you want, like or type it in here or wherever, you know. I would actually be super interested in that. There was a really cool, okay, here's a specific idea that was really funny. You know, in Linux, we've got, they're at the moment they're trying to, migrate everything from X11, like X11 protocol, to Wayland for, the graphic interfaces on desktops and stuff. This guy did it was a really fun talk. He did he implemented the X protocol in Zig in like a really small number of lines of code, but in pure Zig. So it was super interesting, I guess, because I can't remember exactly, but it was talking about how actually just implementing the whole protocol rather than building this like bridge between Wayland and X was so much easier. So it made working with X so much easier because you could just write it in Zig, and Zig, I guess the point was that, hey, like we can use these higher level libraries, a little bit high level language, to write graphic user interfaces. Yeah, I'm super interested in Zig. My friend, who I'm actually going to meet up with now, he's done a few things in Zig, and he's like, Ollie, you have to try it, you have to do it. So I can use it. Oh wow, yeah, right, awesome. Let me just write this up. Parse. The other thing we want to do is let's test. Oh no, we're not going to test. We're just going to like, do more playlist writing, so that what we'll do next time is we'll test, we'll do more writing out HLS playlists. So then what we'll have instead is a, we'll have our like HLS proxy server that does nothing except for, read, parse, and then write it out again. But maybe we can get it to handle things like master playlists and other types of media playlists. Right now, it can only handle the media playlist, so it can only play one type of video, beginning to end. That's it. Yeah. Then we're kind of testing the whole thing a bit more, which is cool. And yeah, that's yeah. Okay, so I think that's Discord would be great. Oh no, come on, guys, not Discord. I maybe IRC or something, or we could do the Twitch chat. I don't know. Yeah, I don't understand the Discord thing. But anyway, that's for later. I've actually never used Discord before, to be fair, so I shouldn't really say anything, right? Nah, not about being old school. Nah. I'm taking. I don't know. Yeah. That would actually be fun, like implement some of those old chat protocols. That would be fun. Yeah, and it'll be fun, right? You got people like writing in. Oh, IRC protocol and go. Yeah. Yeah, that's a cool idea. I think there might be something. I mean, of course there will be something already, but one of the things I love doing is doing it without any dependencies. I think that's always great fun. Yeah, that's right. I know. Yeah, that's so. Yeah, that's the thing I hate when when that happens to protocols. All the like servers out in the wild, they have all these extensions, and then the actual bare standard protocol is like almost, like unusable or whatever. Okay, I think. Yeah, Deus, yeah, sorry, just finishing now. Yeah, it wasn't a super long one, only 4 hours today, so.
Oh, on top of IRC. Yeah, right. Yeah, I remember when Slack had the IRC gateway. That was good. Awesome. Okay. There's the mailing list there, guys. So subscribe to that. We can chat through there. Email forever. Woo. Okay. See you guys. Thanks again. See you next time. It's been so fun. Hope it helps.